today. All right. So for our next session, we have Ambarish Ganguly, who is senior consultant at Tata Consultancy Services. Ambarish holds over 2 decades of experience working with clients in North America, Australia, and the UK, and leads the data and analytics practice and energy trading and risk management practice in TCS Utilities. NASA has recognized his contribution to data science and has acknowledged Ambarish as a NASA citizen scientist. He has a great passion for solving business problems with technology. I'd now like to invite Ambarish to talk about building a deep learning model in Keras, Streamlit Ui, and deploying in AWS Fargate EKS. All yours, Ambarish.
Thank you so much. Let me share my screen. Yes. So the topic today is building a deep learning model in Keras, Streamlit UI, and deploying in AWS Fargate and EKS. Okay. So what we will do, the plan, we have a lot of technologies that is there. So what we will do is that we will create a deep learning model. We'll create a deep learning model, and then we'll create a deep learning inference service. And then on top of it, so the beauty of analytics is that you cannot express it just like that. You require a UI. So nowadays, Streamlit is a very good UI in which you can build very easily. We'll create a Streamlit UI to wrap this up. And then what we will do is that we will use the power of containerization to build a Docker image. And then we will verify in local that the Docker image is running successfully. We'll create a AWS container registry. We'll push the image into the AWS container registry. We'll create a Fargate deployment and also create an EKS deployment. So this is a plan. So let's jump in and see the demo actually. So it is very, very demo centric. So here I have the data set. So what I have done for building a deep learning model, I have got a wine quality data set, an easy data set. And there, the goal is to model the wine quality based on certain tests. So these are the various factors on which the quality of the red wine is determined: fixed acidity, volatile acidity, citric acid, sugar, chlorides, and several other things. There are 11 of them. And the last one is the quality. So this is a regression problem. So what I have done is that this data set is already in Kaggle. So to those who do not know Kaggle, it is a very nice place where you can find a lot of data set. It gives you a lot of uh, data sets and a platform in which you can do things for free. So what I have done is that I have created a deep learning model, the Redwine Quality TensorFlow Scaling. Don't get confused or don't get flustered because everything is in GitHub. So I'll share the GitHub link with you, and everything is public. So what I'm doing here is that I am reading this file, which is a wine quality red.csv. Okay, so the data is here. If you see the data, so the data is here. We are not able to see the data. Okay. Okay. Okay, sorry. This is the data. So the data is already here. So this is the data that is there. So what I am doing is that I am reading this file in the notebook. And then these are the columns which I have said. We have chosen these features, the numerical features, and then we are scaling it. So what is scaling meaning? So it is reducing the features between 0 and 1. So that is a preprocessor. And then what we are doing is that we are dividing into a training and a validation set. And this is a quality uh, which we are trying to predict. And then we are doing a fit transform and a transform. And then what we are doing is that here we'll not, because this session is not about deep learning, we'll not go into the details of deep learning. But essentially what we are doing is that we are building a deep learning model with dense layers, batch normalization, and dropout. This block is being repeated a couple of times, and the last layer is a regression layer. So I have, later on I will show you that there is a series for me in my YouTube channel of how to build deep learning models, but that's fine. So this is, we are compiling the model, we are putting the optimizer as Adam, the loss as MAE, mean absolute error. We are fitting the model, and then we are getting the validation loss. And then we are using, when we are predicting it, what we are doing, we are taking a sample of it, and then we are transforming again, and then we are predicting it. So this model, once the model is built here, if you see the model is built, model is fitted here. So this model, what we will do is that we will save it in a file. So we are saving this in a file, which is a redwine model.h5 in h5 format. And we are also we are also saving the preprocessor thing so that we can utilize it. So this is how we are building the model. Maybe this session is too short to go into the details of the model, but this is how you build a model. So somehow you have built a model, a deep learning model, but how are you going to use it is that you are saving the model file and you are saving the preprocessor file which is needed. So this file is already there, these two files which I will use. Okay, so take for example anything, any model that you are doing, you can do it in this manner. Okay, so once you built a model, what I have done is that I have tried to build a microservice. Okay, so in the microservice, what I am doing is that I have got the files redwine model.h5 and the preprocessor.p. All these things are there. And in the app.py, what I am doing, this is a Flask application. Uh, so what I am doing is that I am going to expose a service here. So here, what is happening? It's the same thing which you have seen before, but now in the Flask application, these are this is a very simple method that I've done, which is slash. But in the predict, what we are doing is that whatever we are getting as a JSON in the request, we are transforming it into a data frame, and we are predicting it after we are transforming it, and then we are converting to a JSON and we are sending it back. And before we do it, what we are doing is that we are loading the preprocessor, and we are also loading the model. So this is already there. So here I have all these models and it is running. So this is a microservice of Flask which is running here. Okay. Now what we do is that now I want to deploy it as a container. So we are talking today about AWS. So we'll deploy it in AWS Fargate, AWS EKS. But tomorrow, if suppose this is a very flexible structure. Tomorrow you are building a product. You want to deploy it into some other place. You want to deploy it in your own local servers, you can do it. So best is containerize it. So for containerizing this, what we are doing is that we will do a Docker file. So Docker file is very simple. This is this is a Debian Linux that we are getting. We are creating the base and we are copying all the files to the app directory, and then we are doing a pip install of the requirements.txt. What is requirements.txt? Requirements.txt is these libraries, which are the dependencies. We are using pandas, sklearn, Flask, TensorFlow. So all this is there, and then we are exposing 5000, which is support, and then we are doing a Python app.py. And so this is how we build the Docker. So how to build the Docker? So the Docker steps are there. In the Docker steps, so what I have done here is that because there is very limited time in our talk, I have already built the image. So how do you do it? You do a Docker build -t redwine flux t, and then what happens in your Docker desktop? It is already there here. So it is redwine flask is already there. So this is how we are building it here. Okay. Now what we do is after this is we have to deploy the whole thing in AWS Fargate and AWS EKS. Okay. So what we will do in AWS Fargate is that, so first of all, we need to push it into the container registry. So what is the steps to push it into the container registry? Is that we will first create a repository in the Elastic Container Registry. So here I have already created that. So here is AWS. Let me log in. So the image is already there. So that's why Elastic Container Registry. So this is a place where it would hold all those images. So I have created this repository. It is a Redwine repo. This is the one that I have created the repository. So we are holding the repository here. So this is a Redwine repo. But the image is in my local desktop, right? It is a Redwine Flask. Also, I have also renamed it to Ambarish G Redwine Flask. So what I'm going to do now is that we'll get the login and password for the ECR registry. So if you see here, what is the thing? It is a region is the region in which I built the registry, and Docker login username is AWS and password stdin. This is my account name dkr.ecr.useast1, that is region dot amazon aws.com. So this I am getting. Again, what I am doing is that this is incorrect. So this is tagging the tag. So what I am doing here is a Redwine Flask latest. What I am doing here is that I am tagging it with this name. So this one is, once I'm tagging it, it is coming out here in my, so you see this is coming out here. So this I am doing it here. Okay, I am tagging this and then I push it into the registry. So this I am doing and pushing it into the registry out here. So it is in the registry, I pushed it. It takes some time. So this one, you see, it is pushed down here and it is in the registry out here. So what is happening till now, what we have done is that we have created a deep learning model. Just a revision. We have created a deep learning model. We have saved the model file. We have got the preprocessor .p. We have put it into microservice, which is this microservice out here. And then we have containerized it by creating a Docker file and then a requirements.txt. And then what we have done till now is that I have pushed all of this into the ECR repository. So everything is done till now. Now, what will happen is that I will do the AWS Fargate. Okay, before I have already done that because it takes a lot of time to do the Fargate, but I will show you the steps of how to do it. So here, if I go to AWS Fargate, AWS ECS, here it is ECS. So how will I do it? I'll just show you of how to do it. You do a get started. You require these three things. You require a container definition, a task definition, a service, and a cluster. Don't get baffled by it. It is very easy. So this is the image. So you do a configure. Uh, I will just show you because this might take some. So you just put your name. So I have done one. So I'll put a red wine too. What is the image? The image already is there in the repository. So this is the image name. Put the image name here. It is running in 5000 port, and then I'll update it. And then I will do a task definition. What is a task definition? A task definition is a blueprint for your application and describes one or more containers through attributes. Some attributes are configured at the task level, but the majority of the attributes are configured per container. So it is a configuration of the container. So I'll do an edit. You can change the name to something. So maybe you can do red wine 2. Let it all remain all the same. And here, because you see my image is around 2 GB, might as well make it 4 GB. So that, and see here, it is requiring a valid CPU. So you make it here 1 VPCU. You save it. All that is done. And then what you do is that you do a next, and the task definition is done. You do an application load balancer, and then you do a next, and then you create a cluster called Redwine cluster 2. So and then what you can do is do a next. So all that is done, and then you can click on create. I will not press create because I've already done it. So what has happened is that I already have one cluster there. So I will leave it as it is. Maybe you can do it on your own later on. But what I will do is that I will go to my Amazon account and I will see whatever I have done before, because this takes around 10 minutes, 8 to 10 minutes to do. So I have created one cluster. I will show you the cluster which I had created, but the steps are exactly the same. So it is ECS. The cluster is Redwine I had created. And now what is happening? It is running. This Redwine service is running. And if you go to the task, and because I have created application load balancer, it also exposes a public API. So it is 3.85.75.38. This is already there. Now the beauty of it is that the service is now running as a container. It is running in the 5000 port, and I can use a very good UI known as a Streamlit UI. So what is the Streamlit UI? I will go here, and I have created one UI which is a Streamlit UI, and there in the URL I have pushed this, the one that I have shown, 3.85.75.38 colon and predict. So if I am already running it here in the Streamlit UI, Streamlit run redwine.py, and it is running um, in my 8501 port. So this is a UI that, and I was telling you, right, that there are so many inputs, and what we are going to do is predicting the wine quality. So this is using that container image, and I'm using that service. So if I do here, if I do a predict wine quality, it is, now you make it maybe say 12, you can see that it changes. See, it is changing. You make the pH as 4, you see that it will change. So this is how what is happening till now is that we have created a deep learning model. We have made it into a container. We have pushed into the AWS, we have created a Fargate deployment. We have picked up the Fargate application load balancer URL that is here. You see this one and this one is the same URL that is there. And what we have done, we have created a very simple Streamlit UI. Maybe in different session, we'll walk through what is that UI. It is a very simple one you can create. So that Streamlit UI is there, and it is just calling that service. So here is the URL. So Control C, Control F. So where is the URL here? Here we are posting the URL and we are getting the data from the screen, and we are getting the predictions. So very simple way in which we have built it. Okay. So this is the Fargate. Now EKS is slightly different. Okay. So the EKS deployment, what we have done is that I will show you the EKS deployment. This EKS deployment, so the request is coming in, we have a network load balancer, and then we have an ingress. The ingress, what it does, it just routes to different services. Here the service is only one, so that's why there is only one service. So this is a way in which you can do it. So I will show you the implementation of that. It's very simple. Now, if you're using EKS, the implementation of EKS is very simple. I put down the steps. What you do is that you create an EKS cluster. So that it takes around 30 minutes to create that cluster. So if I do EKS, Elastic, Elastic Kubernetes service. Yes. So this one, the clusters. Oh. This is a cluster that I have created, AG-Redwine 6. So how did I create it? Just by this command. It's so very easy to create this cluster. We have updated the kube config to this one. And then what I have done is that I have made this structure with the load balancer and the ingress and Nginx uh, ingress controller with this code out here, and this will create the thing. And then I have run the kubectl apply redwine eks ingress.yml. So this is all done because it takes around 30 to 35 minutes, around 40 minutes to create it. So I have already created that AG-Redwine 6. I have run all those things. But what I'll do is that I'll walk you through the meat of this. This YAML file is placed here. Don't worry, there is a lot of information. What I have done is that I have pushed everything in GitHub. It is my GitHub out here. So this recipe, this has a complete documentation, deployment to AWS, all these things are written. All the code that I have been showing till now is written. Only thing that is not there is this Kaggle code. So I'll also update it here. So anyways, so it's already done. And so what I was saying to you is that this EKS cluster is already there. EKS cluster is already there, and we have all these things. And what we do is that we run this Redwine YAML. I'll walk you through that YAML. See, this YAML is very interesting and simple. So what we are doing is that this is a deployment. This is only one replica. So if you want more pods like this here, 3 pods, what I have to do is change these replicas to 3. And then this is an image which is referring to this container image down here, which we have shown. Then there is a service which is a node port service. And then after that, we have an ingress. and this is an Nginx ingress controller, and it is referring to the Redwine service. So all that is done, I have run it, and what has happened is if I go down here, I have the kubectl get ingress. I have this URL out here. So this URL can also be used in my Streamlit UI. So the Streamlit UI, in the Streamlit UI, if I go back again into my Streamlit UI, here, if I just put a hash here, so this is a ingress controller that we are having, and this also will run and give me the same result. So this is a ingress controller that is there. So what I'll do is that if I just stop it and then run again. Now what is happening now? My Streamlit UI is pointing to the um, EKS cluster. So it is now in my EKS cluster. So it is going and getting the EKS cluster. So all this in a space of 23 minutes, what we have done, we have learned a lot of things. It is too much actually in such a short session. Deep learning model, inference service, which is Flux, Streamlit UI, container registry, Fargate, and EKS. All this is very difficult to absorb in 23 minutes. Just to get you to have a flavor that you can do it very easily nowadays with any technology. If you are a data scientist or a citizen scientist or anybody who likes who can create deep learning models, you can create a container image very easily, and you can push into any cloud like an AWS container registry. You can do Fargate, which is very easy as you saw to deploy. EKS is slightly difficult because of all these other things, but eh, I wanted to demonstrate that it is nowadays quite easy to deploy. Previously, it would have taken a lot of pain to do all these things. And the best thing is that all the code is, I have pushed it publicly in GitHub, which is here in this. It is here. All the code is here, and the specific code for this is in Redwine server. You can find it. And another thing that I wish to tell you is that I also have a YouTube channel, which is this one, um, Ambarish G. And I talk a lot about data, machine learning, deep learning, cloud education, and also statistics. So if you like this type of content, please do feel free to watch. And I am continually uploading videos on that. So that's it from me. I'll just pause here and see if there are any questions.
All right. Thank you, Ambarish. That was an amazing session. I guess all of us have a huge takeaway from the session that you just had with us. We'll go forward with the questions. So I think I have a few questions from the AWS community. First of all, the biggest question for all of us: how did you become a NASA citizen scientist?
Oh, okay. So, best thing is that there is a very good link out here. So, I participated in a competition for penguins for estimating the number of penguins. So here I have there is one page for NASA for that. Which talks about it. So they were going to predict the penguin population. Okay, so they had one competition on that. Okay, so and it was run by Driven Data, and I was fortunately my models won the first prize. So if anybody is interested, They can read about this. A lot of things is there. A lot of citizen science projects are there. I'll just post it in the comment also, if everybody is anybody is interested. I cannot post it now. Okay, okay,
You
that's
can
fine.
just share the link with us. We'll post it on the
Okay,
comment
yes,
section
yes,
too.
yes. So this one is the one. So it has got. So it was a penguin population in Antarctica prediction contest, and there were lots of people who were predicting naturally. So fortunately, my models, I tried all of them, and my model was the winning one. So that is how, and I participated with a lot of researchers later on with seabirds. So penguin is a seabird. Okay,
Right.
and so there are they participate in competitions, right? Research papers. So I participated with them in another one competition, wrote a research paper with them. So great guys, good to be associated with them. So I think they were generous, very generous to nominate me as a NASA citizen scientist. So that's how it the story is. But apart from that, what is more intriguing is that if you read this link, I participate in a lot of citizen projects, citizen science projects in Kaggle. So you can see all those various things are there. It ranges from, say, helping school students to find the right mentor, to find the right donations, how you can connect the donors with the right donation plea, all these things. If you're interested, please read. It's the good thing is that there is a lot of variety. The bad thing is that there is a lot of variety, because you might get haywire, but the concept is the same. It's all data science. If you learn one thing, and you don't have to learn a lot of things, learn one thing, then you can apply it in different ways. It can be from penguin population to bees, to helping police also to guide them that which places you should be tracking for crimes and helping out people, so all these things.
Wow, I mean, these all projects sound amazing, and
Yes, they
clearly,
are. Yes, they are amazing. And Kaggle, do do see Kaggle. There are lots of amazing projects, and there are more. There are like the lot of good people around there. And the best thing is that I like the community. I do not win most of all the time. I lose. So, but what is happening is that you learn a lot from the best. They're the best in the world. So, so
I'm
that's the
sorry
thing.
you're being very humble here, but
Mhm,
come on, I mean,
mhm.
it's amazing listening from you. All right, so I just would also like to ask you another question, like how, I mean, if you could tell us in brief about your 23 years of experience at TCS.
Yes, that's a very great question. So I started off straight from college, as you can see, and then I was with product development team, which was a CAD development team, but we
Okay.
developed the internals of. So when a file in CAD opens, there's a lot of thing goes on. So that's another amazing thing I was exposed in the first 3 years of my development experience. Then I moved into more client facing roles, and then as a developer, then as an analyst, and then as a project manager, then as a business relationship manager, then as an architect, solution architect, and now I am the practice lead of two very interesting things. One is data analytics, and another is energy trading. So as shares trade in the market, energy also gets traded in the market, but that is not very common for most people, like, because we do not see it in India, but it is traded in India, but in other countries, like, it is traded more frequently. So I lead those two practices. So that's the whole story. 22 years is a long time. So,
Very long
so,
time, sure.
mhm.
All right. I think we have another question from Rohit
Yeah.
Kumar. So
Yes.
how to choose projects from Kaggle which could help us in our career?
Yes. So first is you look out for analytics projects, and also you choose any competition. Just join the competition, even if you don't know anything. First thing is that you read the problem statement, then you think about it, how I can solve it, and then there will be a lot of public kernels out there. Choose the kernels made by the experts, the grandmasters, and learn from them. I learned mostly from them is that I would go to the kernel, take one line, copy the one line in my notebook, run it, and understand why they are doing it, then copy another line. In this way, what is happening is that instead of going through a very thick book and listening to lectures, what you can do is that you can learn by doing. And since it is very active learning, you learn faster. And do you know what? Once you start copy pasting things with uh, intention that you are learning, then what you develop your own library that you can use later. So that is what how I did with all these competitions. It's a very simple thing. Only thing that you require, which is the most important thing, is time.
All right, that
That's the
was,
only thing.
I'm sure that helped all of us here. I think there's
Mhm.
another question. As a beginner, how should I
Yeah.
start my journey with ML and deep learning?
Yes. So one thing is that I won't say go into statistics or everything at first. Best thing is that you can go to Kaggle Learn. Learn. There are lots of free courses. Learn them. And I also have my channel out here, which I'm trying a little bit to help people to learn. So you see this channel also. But I would strongly recommend go to Kaggle Learn and learn. There is a lot of good courses out there. So I have so there is a Kaggle Learn deep learning course also, intro to deep learning. So I made videos of that also, so you can do that. But as such, I would say start with Kaggle Learn. It's easy because you are in more active learning. Otherwise, reading books is a little bit difficult for most of us. So,
I agree.
and
I agree.
then once you are comfortable, learn a bit of statistics and matrices. I'm
Right.
sure that in your college or somewhere in school, you've learned all these things, but somewhere it has got lost or you've gone a bit rusty. It's time
Sure.
that you can
Yes.
revise those things. It will be great, actually.
All right. That was again a wonderful answer. Thank you so much, Amrish, for the
Mhm.
beautiful session that you've taken. I'd just like to inform everyone in our audience that we've had another quiz for this session. The quiz link is on the screen, as you can see. Quiz T2S4.awsug.asia. Please participate in that. Again, thank you so much for coming to this community day and
Thank you.
giving a wonderful session. Angel, over to you.
Build, 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 build. Go, go, build, build, build. Go, 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 build. Go build, go build, go build, go build, go build, go build, go build. There is no compression algorithm for experience. Def and test, def and test, def and test are the most important workloads. Dance like nobody's watching. 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 Encrypt like everyone is.